This is activity 2, tables, graphs, and equations for lesson 13. 2 graphs for each relationship. And these are some summary ideas for this activity. And the main point behind this activity, and this will become clearer as we look at problems in context, actually using some numbers. But if you have a proportional relationship identified by this graph, and the x-coordinate is A, the y-coordinate is B, that ratio of B to A is the constant of proportionality. So the constant of proportionality is B divided by A, and that shows up as the y-coordinate right here when the x-coordinate is 1. And you can see that in the equation. So you have B units for every A units. So the length of y for every unit measure of the length of x. And so that's the constant of proportionality. You have that ratio B over A units for every unit of x. And that shows up in the equation. Y is equal to kx. So B over A is k. That's y over x. This is the y coordinate. This is the x coordinate. So y is equal to that ratio times x. Now when x is 1, y is equal to B over A. And it's not that intuitive. It's not that easily seen, not that obvious. I'm going to go through some examples, and hopefully it'll make it easier to understand. Okay, in this activity, students are to choose one of these 3 points. So A is at point 10.4, B is at point 4.5, and C is at point 8.5. And I'm going to go ahead and work with all 3 of those points and try to do them together, see if you can follow along. And so it's supposed to put together tables for each of these points. So if you have point A, which is at the x-coordinate is 10 and the y-coordinate is 4, you can go right down here to the x-coordinate is 10 and fill in the y-coordinate as 4. Then that shows you or tells you what the constant of proportionality is going to be. These are proportional relationships. So a point through, or a graph through each of these points is also going to go through 0, 0. The relationship is proportional. So that means you have a constant of proportionality, which is the y-coordinate divided by the x-coordinate. So it's 4 divided by 10, which actually simplifies to 2/5. You don't necessarily have to do that throughout. And so if we start filling this in, first of all, 0 times 4/10. So remember, the constant of proportionality is what you are going to multiply x by to get the value of y in every case, because it's constant, it's proportional, it's that relationship. So the value of x multiplied by the constant of proportionality, so 1 times 4/10 equals 4/10. And something else we're going to look at in detail is what happens when x is equal to 1, y is equal to that constant of proportionality, because 4/10 divided by 1 is 4/10. 2 times 4/10. So now we're going to look at multiples of that constant. So 2 times 4/10 is equal to 8/10. And if you divide 8/10 divided by 2, that's 8 divided by 2 of these things called tenths. I have 8/10. I divide that into 2 groups, or I divide it by 2. Now I have 4/10 in each group. Same with 3 times 4/10 equals 12/10. Well, 12/10, 12 of something divided into 3 parts, or 3 groups, is equal to 4 of those things called tenths. 4 times 4/10 equals 16/10. 16/10 divided by 4. So what I'm doing here is taking the y-coordinate and dividing it by the x-coordinate. That's the constant of proportionality. So y divided by x gets you back to the constant of proportionality of 4/10. So you multiply by that constant of proportionality. 5 times 4/10 equals 20/10. Now if I divide by 5, that's going to get me back to that constant of proportionality. It makes sense. Multiply by 5 and then divide by 5. For B, the x-coordinate is 4, the y-coordinate is 5. So you can go right down here to x is 4, y is 5. The constant of proportionality then is going to be that ratio. So for every 5 units along the y-axis, you're going to get 4 units along the x-axis. Actually, it's better said the x-coordinate first. So for every 4 units along the x-axis, you're going to go up 5 units along the y-axis. It's better thought of that way. X is the first value that you think of. So 4 times 5/4 is 20/4, and so equals 5. And so 5 divided by that 4 gets you back to 5/4. So it's a little bit larger than an equal amount. So it's 1/4 larger. Actually, it's 5/4 of whatever you're multiplying by. All right, so for 5 times that constant proportionality, 5 times 5/4 equals 25/4. Now, if I multiplied 5 by 5 and then I divide by 5, I'm going to get back to 5/4. 25 divided by 5 is 5, but it's fourths I'm talking about. So now I have 5/4. And for point C, 8 is the x-coordinate, 5 is the y-coordinate, so the constant proportionality is going to be 5/8, or 5/8. So each one of these x-coordinates is going to be multiplied by that constant, or 5/8. So that tells you that for every 8 units of x, y is going to go up 5 units. So then it's 8 units of x, y is going to be 5 units. So the length of y is 5/8 the length of x. It's a fraction of the length of x. It's 5/8 of the length of x. And so 1 unit along the x-axis times that 5/8 tells you that the y-axis is 5/8. It's 5/8 of 1. So 5/8 divided by 1 is 5/8. For 2 units along the x-axis, it's 5/8 of 2, or 2 times 5/8. 3 units along the x-axis is 5/8 times 3, or 3 times 5/8. So the length along the y-axis is 15/8. That's 5/8 of 3. And 15/8 simplifies to 1 7/8. So it's a little bit more than half the length of the x-coordinate. So 4 times 5/8 is 28. 20 divided by 8 is 2 4/8, or 2.5, which is a little bit more than half of 4. So you're always multiplying by that constant proportionality. That's the relationship between the length along the y-axis and the length along the x-axis. So now we're going to take a look at these on the graph, and hopefully this will be a little bit clearer. So let's look at A first. So A is the x-coordinate is 10, the y-coordinate is 4, so that means that this length along the y-axis is 4/10. 4/10, 4/10 the length along the x-axis. So now if I look at the scaled copy of this triangle, so this is a larger triangle, and if I look at the scaled copy of that triangle, it gets me down to 1 unit along the x-axis. That means the y-coordinate is going to be 4/10. So the y-coordinate is always 4/10 the x-coordinate. So if I have 2 units, then the y-coordinate is 2 times 4/10. So this is 4/10 and another 4/10. 3 units is 3 times 4/10. 4/10, 8/10, 12/10. 12/10 right here. If I skip over to 5, this is going to be 5 times 4/10. So the x-coordinate is 5 units. The y-coordinate is going to be 4/10 of 5. So 5 times 4/10 is 20/10, which is 2. 20 divided by 10 is 2. So let's try that again with the C point. So the x-coordinate is 8, the y-coordinate is 5, and that says for every length along the x-axis, the length along the y-axis is going to be 5/8 of the length along the x-axis. It's going to be 5/8 of x. So if I scale this down to 1 unit along the x-axis, that means the y-coordinate is going to be 5/8 of 1. So it's a little bit more than half of 1. So if I have 2 units along the x-axis, then the y-axis is going to be 2 times 5/8, which is 5/8 of 2, 5/8 of 3, 5/8 of 4. So 4 times 5/8 is the same as 5/8 of 4. And then finally 5/8 of 5, or 5 times 5/8. So again, the length along the y-axis is 5/8. It's this fraction of the length along the x-axis. And finally, for point B, the x-coordinate is 4 and the y-coordinate is 5. So notice that the length along the y-axis now is a little bit longer than the length along the x-axis. Actually, it's 1/4 of x longer than what x is. So if x is 1 unit, y is 5/4 of 1. If x is 2 units, y is 5/4 of 2. So 5/4 of 2 is 10/4. That is equal to 2 and 1/4 of 2. So 10/4. If it's 3 units long, this is 5/4 of 3, or 15/4. 4 units long is 5/4 of 4, or 20/4. Well, 20 divided by 4 is 5 units. And finally, if x is 5 units, then this is 5/4 of 5, or 5 times 5/4. So you just have to keep going over this and trying to get used to, get comfortable with what's going on. So now we're going to summarize this a little bit. So for each of these, you can write an equation. So you go back to this form, y equals kx. And so that means that this y-coordinate is going to be equal to y over x. K is the y coordinate divided by the x-coordinate. So it's going to be 4/10 of the x-coordinate. So y is 4/10 the length of x. And 4/10 can be simplified to 2/5. B, the constant of proportionality, is 5/4. So y is 5/4 the length of x. So it's a little bit longer. So the length along the y-axis is a little bit longer than the length along the x-axis. It's 5/4 of this length. And for C, it's just a little bit more than half the length. 4/8 would be half. 5/8 is a little bit more than half. So the y-coordinate is 5/8, whatever the x-coordinate is. So if the x-coordinate is 8, the y-coordinate is going to be 5/8 times 8, or 5. All right, so here's a long summary. So it says, what are some things that are the same, and what's different about the tables, the equations, the graphs? Well, first of all, the numbers are different. But number 2, in each case, when x is 1, y is the constant of proportionality. And that's a key point behind this, and we'll look at that in a little bit more detail in a moment. Y is a multiple of the constant of proportionality. So in these tables, you're always looking at a multiple of the constant of proportionality. 1 times the constant, 2 times that constant, 3 times that constant, 4 times that constant. You're always multiplying. The y-coordinate is a multiple of the constant of proportionality. 1 times, 2 times, 3 times, 4 times, whatever it might be. When x is the denominator of the constant of proportionality, so x is here as the denominator, then y is going to equal the numerator. Because what happens is that x divided by x is 1, and so you're left with y. So y equals y. Each equation takes the form of y equals kx. And so the constant of proportionality is the y-coordinate divided by the x-coordinate. That's that relationship that we're looking at in these graphs. So y divided by x, that's the relationship of y to x. Each graph goes to the origin. For every point on the graph, the value of y, the number of units of y, is related to the value of x, the number of units of x. In the same way, it's being multiplied by that constant of proportionality. So for each graph, the y-coordinate is related to the x-coordinate by multiplying by that constant of proportionality. So y is either a fraction of x or a multiple of x using that constant of proportionality. The greater the constant proportionality, the steeper the graph. All right, so more of a summary. So point A is 10, 4. What happens to y when x is 1? Well, y becomes the constant proportionality, 4 over 10. Y, when x is 1, y becomes that constant proportionality, 5 over 4. Or when x is 1, y becomes the constant proportionality, or 5 over 8. So here's a little mini table right here to show that to you. So we start out with 10 as the x-coordinate, 4 as the y-coordinate. Constant proportionality is 4/10. When you go to 1, y is equal to that 4/10, because 1 times 4/10 equals 4/10. For b, x is 4, y is 5, so the constant proportionality is 5/4. When x is 1, y is that constant, is 5/4, 5 divided by 4. And c, when x is 8 and y is 5, the constant proportionality is 5/8. So when x is 1, y becomes that constant of proportionality. So y is equal to 4/10 of x, y is equal to 5/4 of x, and y is equal to 5/8 of x. So basically what you're figuring out is what's the length along the y-axis compared to the length along the x-axis, and it's a multiple or a fraction. It's multiplying by that constant of proportionality. So if you go through, y increases by that multiple. So you increase the units of x. So x is 1, 2, 3, 4. Y increases by that multiple of the constant proportionality. So you're multiplying by 4/10, 4/10, 4/10, 4/10. So you get down to here, it's x times this constant of proportionality is equal to y. So this is constant, it's not ever changing. So that's why it's called k, or the constant of proportionality. And so y equals kx. For b, 1, 2 times 5/4 gives you the value for y. This is simplified to a mixed number, 1 1/4 or 2 2/4. So you have, again, x times k equals y. So you can rewrite that equation as y. So the y-coordinate is equal to the constant of proportionality times x. It's related to x in that way by multiplying by the constant of proportionality. So y is a constant multiple of x. In this case, y is 4/10 the value of x. For b, y is a constant multiple of x. Y is 5/4 the value of x. And for c, y is going to be 5/8 the value of x. So notice that the length along the y-axis is 5 units compared to 8 units along the x-axis. So y is 5/8 of that length along the x-axis. So now what I'm going to do is go into more of a visual explanation of this, because this is tough. They have you go through tables and graphs and equations, and see if this helps out a little bit. So point A is the y-coordinate is 4, the x-coordinate is 10. So imagine that I have 4 rectangles, and I'm going to divide these 4 rectangles among these 10 groups. So this is 4 over 10, which is the constant of proportionality. So now I shaded these in such a way, I want to use squares, but if I shade all these squares, then it's hard to see that. So I just identified the remaining squares as these dots, so you can see what's going on. So now I'm going to divide these 4 whole rectangles among these 10 groups. Well, I don't have enough rectangles to give a whole rectangle to each group, so I had to chop these up. And it makes sense, since I have 10 groups, it makes sense to chop each of these rectangles up into 10 parts. And so now I can give each group, in this case, 1/10. So I distribute this whole rectangle. This is made up of 10 of these squares. I can give one of those squares to each group. I can do the same thing with the second rectangle. Now each group has 2/10, so 2 of these squares. I can do the same thing with the third rectangle. Each group now has 3/10, and I can do the same thing with the fourth rectangle. So each group now has 4/10. So if I have 4 whole rectangles divided among 10 groups, imagine you have $4 divided among 10 people. Same idea. How much money is each group going to get? Or how much money is each person going to get? Or what fraction of a rectangle is each group going to get? Well, each group, so one group, gets 4/10. So if you have A at the point 10, 4, then for one group, or at x equals 1, y is going to be 4/10. So on a graph, here are the 10 squares, and the y coordinate is 4 squares. So it goes out 10, goes up 4. So it goes out this way 10 units, goes up this way 4 units. And this is a scaled copy down here. The small triangle down here is a scaled copy of this larger triangle, and the scale factor is 1/10. So 1/10 of 10 is 1. 1/10 of 4 is 4/10. So this length is 4/10 of 1 unit. So this length right here is 4/10 of 10 units. So wherever you go on this graph, the y coordinate is going to be 4/10 of the x coordinate. To get out to this point right here and to get up to here, this length right here is going to be 4/10 of whatever this length is. So A is 10, 4. And another point on this graph is when x is 1, y is 4/10. So let's try the same thing when y is 5 and x is 4. So now I have 5 rectangles. I'm going to divide up among 4 groups. Or imagine I have $5, and I'm going to divide those $5 among 4 people. So that ratio is 5/4. So now I can give a whole rectangle to each group because I have more rectangles than I have groups. So if you're dividing money once again, I can give each person, because I have $5 to start with, and I only have 4 people to divide that money up amongst, I can give each person a whole dollar. I can give each group a whole rectangle. Now I have one left over, and now I have to chop this up into parts, and it makes sense to chop this up into fourths. So now I can give 1/4 to each of these groups. So this 5 whole rectangles divided by 4 groups means that I have 5/4 of a rectangle in one group, or 5/4 of a dollar, $1.25 per person if you're talking about money. So for the 0.45 on that graph is also going to be the point when x is 1, y is 5/4. And 5/4, remember, is also the constant of proportionality. So on the graph, this is 4 units along the x-axis. So wherever I go along the x-axis, the length along the y-axis is going to be 5/4 of that length. So this is 4 units. This is going to be 5/4 of 4, or 5 units. So if this is 4 units, this will be 5 units. This gets you out to 0.45. Now this is a scale copy of the larger rectangle. It is 1/4. The scale factor is 1/4. So 1/4 of 4 is 1, and 1/4 of 5 is 5/4. It's right here. So it's a little bit larger. It's 1/4 longer along the y-axis than it is along the x-axis, than the length is, that side length is along the x-axis. So again, 4, 5. So when x is 1, y is 5/4. And that is that constant of proportionality. Wherever I am on the x-axis, I go up to the y-axis. This point right here, the length along the y-axis, the length along the y-axis is going to be 5/4 of whatever this length is along the x-axis. All right, one last time. I have 5 whole rectangles now, so the y-coordinate is 5. The x-coordinate now is 8. So I'm going to divide 5 up among 8 parts. I'm going to look at what that ratio is of 5/8. So if the length along the x-axis is 8, the length along the y-axis is 5. It's 5/8 of that length along the x-axis. All right, so I'm going to divide these 5 rectangles up among 8 groups. Well, I don't have enough to go around, so I need to chop these up, and it makes sense, since I have 8 groups, to chop each one of these up into 8 parts. So that's what I'm going to do. And now I can give 8s out to each of these groups. And so I can give this whole rectangle out to each of these 8 groups because I divided it up into 8s. So that's 1/8. This is 2/8 that goes into each group. This is 3/8 that goes into each group, 4/8 that goes into each group, and finally 5/8 that goes into each group. So how much do I have in one group, or one unit along the x-axis, is equal to 5/8. A little bit more than half the size of the x coordinate. So if x is 8, y is 5, that relationship, that constant proportionality is 5/8. So that means that when x is 1, y is equal to this ratio, 5/8. So if I go out 8 units, y is going to be 5 units. So 8 units, y is 5 units. So the relationship of the length along the x-axis to the length along the y-axis is that the length along the y-axis is 5/8 of that length along the x-axis. So if I scale this triangle down to the x coordinate equals 1, then that means the y coordinate is going to be 1/8 of 5. So 1/8 times 8 is 1. So 1/8 of 5 is 5/8. So this length is less than that length along the x-axis. A little bit more than half. 4/8 would be half. 5/8 is 1/8 more than half. So if for point C, the x coordinate is 8, the y coordinate is 5, and so that means on that same graph, that same relationship, when the x coordinate is 1, the y coordinate is 5/8. This is the whole point behind this activity.